So is my screen visible? Okay, so now first of all, let me introduce myself. My name is Ashwini Jena. I belong to Bhubaneswar city of Orissa state. Professionally, I'm a civil engineer and I have 2 years experience in this process in this profession. And now I am learning data science for a career transition into data science field. So coming to the topic, so for today, I'll be explaining you the an unsupervised machine learning algorithm, which is k-means clustering, which will help us in clustering our data into different clusters. So first of all, okay, so as we already know that we have two types of two different types of machine learning algorithms. So one is supervised machine learning and second is unsupervised machine learning. So in supervised machine learning, we have both independent features and also independent features. But in unsupervised machine learning, we do not have the data labels or the output column. We do not have that. We only have the independent features. So so in that case, we need to determine how to label them, or we need to give them we need to classify the data set into different labels. Okay. So for that reason only, this clustering helps us. At that situation, the clustering is very much important. And to understand this clustering, in if I want to explain you in the very simple way, I can say that clustering is a grouping of similar things. Okay, it is a process of grouping data samples together into clusters based on certain feature. Okay, so the points are very closely related, so that's why we are able to uh, separate them into different clusters. Okay, so for clustering process only, this k-means clustering is very much useful. And let's know about the internal working of this k-means clustering algorithm. So let me show you this graph. Okay, this okay. So in this this is the whole process. I'll be able to explain you here only. So if you focus here on the first graph, this is the graph of this is a 2D graph, and suppose this is a data set, and here I am plotting all the data points of the data set. Okay, so uh, we can see that generally here two clusters are present. Okay, since it is a 2D data and very much small data, we are able to know that there are two clusters present here. So our first step will be, we will be taking 2 points, two random points, which is called k, which is yes, which is k, and we take the value of k according to the number of clusters we have. Since here we have two number of clusters, we will take the value of k as 2. How this value of k is decided, I'll just tell you in a little bit of time. So first we will take randomly 2 points, extra 2 points other than this data set. Here you can see 2 points are here, this red, and this one is blue. Okay, then it is also called centroid points. Okay, so in the next step, we will try to calculate the Euclidean distance between this centroid point and all the data points. Okay, and here this here this red points are nearer to this red centroid, and this blue points are nearer to this blue centroid. So that's why now we can divide them, this whole data set, into two individual clusters, red one on one side and blue one on another side, including these 2 points also. Okay, so after creating two clusters, this we will calculate a mean of these red points, and first we'll calculate for the red points, and next then after that we'll calculate for this blue points. Mean will be calculated based on x axis and y axis. So the mean will come around, will fall between this in this middle, at the middle point of the whole cluster. Same thing will happen in this blue dot for this blue cluster also. Okay, this is the logic for this algorithm. Otherwise, if this is a common sense, that suppose you think of a situation where I am trying to balance a piece of long wood on a wall, suppose. Okay, so it will be balanced if the centroid is kept on the wall. Okay, suppose I am trying to place a heavy rock or heavy stone on the one side or the left side of the wood. So what will happen? The centroid will shift towards the heavy part, and the balance will be affected. So similarly, when the data on the centroid point was here, and when all these points were added to this side, the similarly this becomes heavier, and this centroid point, the tendency of the centroid is to remain at the center only. So it will try to move towards the center of this cluster. So it will move. It has come to this place. The similar process has happened with the blue cluster also. Okay, then again the calculation of this distance between the blue data points and the centroid is calculated, and after calculation we got to know that these two blue points are nearer to this centroid, nearer to this cluster, so they are now included into red, and these red points are included into the blue cluster. Okay, so now again, since the cluster is rearranged now, so again the centroid point will shift towards the center of the whole cluster. You should focus on one thing here, that these data points are not getting shifted. Only the centroid is getting shifted. Data points are remaining at their own places only. So this process will continue until and unless this centroid becomes stable at one point. It doesn't move to any further. It doesn't move any further, and it becomes stable. So at that point, our this cluster, uh, we have got this final cluster. We have got this red one, and we have got this blue one. Okay, so this was the working of the whole algorithm, but it is very much tricky that how we are able to take the value of k as 2, because in k, if we have got a very big data set, we will be unable to recognize how much clusters it is forming. So to know the value of k, there is this elbow method. It is also a hyperparameter of this algorithm. To understand this, you need to know one thing, that is uh, within cluster sum of square. It is WCSS. So now how this WCSS is calculated? Take this graph for example. You can see here this, it has three clusters. Okay, forget about that, it has three clusters. Now take this whole as one cluster. Okay, if this whole, we are considering this whole as one cluster, so the centroid will be at the center. So at that point, we'll calculate the distance between the centroid. We'll calculate the centroid and uh, the data points. Okay, and we will write here. It will when the cluster was one, and what was the distance. It will be written here. Then with the next step, we'll try to create two clusters. Suppose this red one is one cluster, and we are taking these two clusters as one cluster. Okay, this green one and blue one. So when these two clusters are formed, centroid will also be two. The centroid for this red cluster, it will be in the middle, and for this cluster, the centroid will be somewhere in the middle of these. So the distance between the points and the centroid will decrease a little bit. Okay, then the summation of all this distance will be written here, will be added. Again, we will try to create three clusters, and and we'll again calculate the distance between the centroid and the data points, and then we will add all of them, and we will get our WCSS. Okay, so obviously we will able to know that when this value of k or the number of clusters are increasing, the value of WCSS will be decreasing, because uh, when there was a bigger cluster, the distance was larger. But when we try to create more clusters, the centroid tried to get inside the clusters, and the distance become shorter. So that's why at the end we will be getting a graph like this. This is as this it is forming a elbow shaped graph here. That's why it is called elbow method. Okay. uh, at a point at first at a point, first of all, in the first step, we will get the value of WCSS will decrease very drastically. Okay, but at some point it will try to become parallel with the x-axis, somewhat parallel with the x-axis. The difference will not be that significant. Okay, at some point it will try to be a steep slope. So that point is taken as the optimal value of k, and uh, number of that k will be taken as the number of clusters. Okay, and next I have this. These are the application of clustering. It is helps us in statistical analysis, and mainly it is used for recommendation systems and customer segmentation. And so yeah, so if let me show you the Python implementation also, how it is done. Okay, so yeah, this is the Python implementation. Suppose I have taken this data set. So here the columns are CGPA and IQ. Suppose we are a placement team of a college, and we need to collect the numbers of the students so that we can train them for placements. Okay, so we need to know the divide the students into cluster and try to train the weaker students. Okay, so when I'm trying to plot this graph, I'm getting this type of clusters, 4 clusters. Okay, so I'm importing the k-means algorithm, and here I am using a for loop, so that uh, so it is giving me number of clusters when I'm dividing the whole data set into number of clusters, and which observation is from which cluster. Okay, so suppose for an example, this is 0 1 2 3. Okay, this is the situation when the data set is divided into 3 clusters. So the first row is from third cluster, second is from number 2 cluster, and the third one is from 0 cluster, and so on. Okay, uh, so now I am here trying to show you the WCSS, how it is calculated. It is also called inertia. It is in the hyperparameter only. It is also the WCSS also called inertia. So for every point, if I'm trying to see the WCSS, you can see this drastic change. It was 30,000 and it decreased to somewhat 4,100. Okay, so it is forming a graph line plot of this type. Okay, so here at k equal to 4, it is forming a parallel line to the x-axis. So I got that 4 is my optimal value for k, or the number of clusters. So now uh, so this is y means. Okay, now my data set is divided into 4 clusters, and the rows are divided into different clusters, are put into different clusters. And in this step, this is nothing, this is only the Boolean indexing. Suppose I am separating them into different clusters. Okay, so here you can see it is the students who are put into the third cluster. Here are their data. Okay, so here this is the CGPA and this is the IQ. So here I am only taking the IQ, And similarly, if I am trying to put this into the graph and try to divide them into different clusters and colors. Okay, so it is able to divide it. I am able to divide it into different type of clusters, four number of clusters. Okay, so this was the Python implementation. So if you have any doubt, you can unmute and ask. Okay, you so you don't have any doubts. Okay. Okay, I'm ending this meeting.